Okay, so hi there, year 9. So I thought I'd do a series of lessons where we just got a bit more interaction with the theory. So what I've done here is I'm just going to set up a theory lesson with you and talk my way through it. You can see you've got my nice face down the bottom there, but at least you can see me talking. I know it's difficult times at the moment through this pandemic, and I know that we've not had much chance to get into lessons, but hopefully that will improve as September comes. Okay, so the first thing we're going to do is just go through the lesson objectives today. If you've got a pen and paper handy, that would be great. You can obviously pause the video if you want to get that. Alright, so what we're going to look at today is we're going to look at forces and stresses on materials and objects. Okay, so there's a little starter for you here. So what I'd like to do is to try and work out which of these items have got a type of force or stress upon them. Okay, so I'll give you an example being that something is a piece of paper here, and obviously that would be folded. Okay, so just going to give you a couple of minutes. I'm going to just you can pause the video and then we'll come back and we'll show the answers. Okay, so hopefully you've paused it, and we'll go and show the answers. So the answers are as follows. Folding, pretty obvious one with a piece of paper. Some of these words you're going to be familiar with, some unfamiliar with. Bending, person bending a bar, fairly straightforward. Tension, where you've got a tug of war and then there is tension between the rope. To shear is to split an object in two different directions, so a piece of wood that's been split, one going one way, one going the other. Or if you think about a pair of shears, like a pair of scissors, the surfaces are going apart. We got compression, where something like a spring is pushed together. And then the last one we've got is torsion, which is if you think about a tea towel or a sponge being sort of twisted, then that would be put under torsion. Okay, so lesson objectives for today. We're going to understand the terms tension, compression, bending, torsion, shear, forces and stresses, and then what impact the different forces and stresses have on certain materials. Okay, so an applied force is either static or dynamic. Dynamic, working or lifting a load, is a force that will be applied to the linear actuator while it's in motion, such as a ruler resting on a table does not move. Okay, so this is a force applied to something that is in a dynamic position. Okay, a static load is also called a holding load. It's a force that will be applied to the linear actuator when it's not in motion. The same ruler dropped onto a table from different heights does move. Dynamic, much greater force than static. Okay, so all you need to think about is static force is something which is applied where something is still, and a dynamic force is something which is applied where something is in motion. Okay, hence the word dynamic, hence the word static. Designers must consider the strains and stresses on forces of all the products that they design. So we're going to go through just the forces. So tension may be described as pulling, the pulling force transmitted by the means of a string or cable or chain or a similar one-dimensional continuous object. Okay, so tension is where something is being pulled apart. Okay, so again, think about a tug of war and a piece of rope and a tug of war, and then we can measure what we call the tensile strength of that material. So something has a really strong tensile strength, then it means that it's more difficult to pull apart. Okay, so for instance, A piece of paper, if you pulled a piece of paper apart, the tensile strength is much weaker than a steel bar if you pulled that apart. Okay. Right, compression, very easy to understand. Compression is the application of a balanced inward pushing forces to different points of material. So again, a spring is a great example. So when you're pushing the force down, the compression strength is the ability of the material to resist that pushing. Okay, if you think about a car spring under the suspension, obviously that's trying to resist some kind of force, whether it be the road or the load that's in the car. Aeroplane going over. So next one is what we call torsion force. So this is the ability to withstand an object that has been twisted. And again, if you measure the torsion strength of something, a tea towel being wrung out would have a low torsion, whereas if you've got a piece of wood and you try and twist it, obviously that's going to be very difficult. So this has a much higher torsion strength than this. Okay, bending. So bending again is very straightforward. Wait for that plane to go. So a bending force is a combination of tension and compression. Bending operations, bottom bending is used frequently at the bottom dead center in order to stabilize the shape. Stiffness is the ability of the material to withstand bending. So you can bend a bar, all right, but what you need to remember is if you bend a bar, it actually causes two other forces. So bending this piece of material here would mean that the top part is stretching under tension and the middle part underneath the material would be compressing. Okay, if you imagine that this is a piece of metal, the metal would be stretched at the top but then being pushed together underneath. Okay, if you apply a bending force on either side. Okay, shear forces are aligned forces pushing a part of the body in one direction against another part of the body in the opposite direction. When the forces are aligned to each other, they're called compression forces. Imagine fabric shears cutting into a cloth. So these two elements here, okay, would be shearing against each other. Okay, they would shear the surfaces against each other. So a bit sort of like this sort of motion. Okay, where two surfaces are shearing against each other. That's what we call a shear force. Okay, so little question for you here. Let's see if we can do this. So look at the chair that you're sat on. Okay, hopefully you're on a chair. What forces and stresses occur on the object that you are sat on? Okay, so here's a school chair. Here's a chair for a computer desk. So if you're sat on this, what forces are being applied to that chair? Okay, just want you to pause the video there, pause it, okay, and then just have a little think and go back to that question. So look at the chair you're sat on. What are the forces and stresses occurring on this object here? Okay, so if I'm sat down on this chair here, this my chair is under some kind of force. All right, what would that be? Okay, so answer to that would be a compression force, because obviously the weight of the person is compressing down on the seat, so compression force. And then what we've also got here is tension, because as the force sits on the seat, the legs will want to sort of split out. Okay, they want to move apart because and that makes those legs under tension. All right, if the person gets up, the legs will sort of come back in slightly. If you put an incredibly heavy object on there, those legs would completely give away under tension. Right, you might also have what we have a piece of bending here. So if you lean back on the chair, you might get a bit of bending. Okay, and also because it's being bent, this area here would compress slightly and this area here would be under tension. Okay, so a whole series of different forces being applied. Okay, how products are strengthened. So the material that strengthens existing material when adding to it are called reinforced materials. So what this means is that we will take a piece of material, and what we'll do is we will add something to it to reinforce it, to make it much stronger than it actually is. So concrete is a really good example. So concrete is good in compression but weak in tension. So to increase the tensile strength of the concrete, we are in reinforced material called reinforced steel. Okay, and here's some pictures here, and you see this when we are building houses, or if we're building something like a factory or a car park. So if they just made this completely just out of concrete, the concrete would still be relatively strong, but it would have a bit of a liability for things like cracking and flaking, especially if it's out in the sun. So what the builders do is that when they lay foundations for houses, is they'll very often put a steel reinforced mesh or concrete bar through the concrete. Okay, and what that does is it reinforces it. It's what we call some kind of metal structure. So that's what we call reinforced concrete. Okay, and that appears in majority of buildings when you see it being built. Okay, another product would be tyres, car tyres. So if you've ever seen the inside of a car tyre or even a bike tyre, you'll know for a fact that if you run this on pure rubber, okay, it's going to wear down incredibly quickly. But if you cut into a tyre, a bicycle tyre or a car tyre, you'll see there's lots of woven sort of material underneath, almost like an inner liner. So there are several layers. Okay, there's a layer even on the inside. There's several layers that reinforces that rubber to make it a bit longer lasting. Okay, this also happens in textiles. So a good example would be a pair of jeans, because the denim is very strong, quite thick material, where you've got major sort of stress on the items. Where you've got major stress on the items, like the pockets, you'll see that they're riveted together. Okay, it goes all the way through the materials, and that way it makes the textile reinforced. Okay, there's other ways in which you can do this. So we can add a series of different methods in school to reinforce some materials. So we can stiffen materials by laminating or folding them, and then injection molded items. So plastics can also have sort of like a rib of plastic on the inside to strengthen it. So a piece of paper can be laminated between a sheet, and that piece of paper can obviously be strengthened by the lamination. Sometimes we have a belt where we can have woven bits of fabric inside, and we can make that much stronger. So something like Kelvar can be, or nylon can be woven in. That goes on things like belts or the sort of straps on your rucksack. We can put several layers of wood together by laminating them. We have corrugated card that has many layers of corrugated card in between. It makes the card reinforced, also makes it slightly breathable. And then what we can also do is, by saving on materials and helping points of stress, is to create curves on our products, as you can see here. If this had two pieces that were joined together at 45 degrees, they would be quite weak, whereas you curve it into one piece, it makes it a lot stronger. Okay, so just to remind you, compression, okay, is the forces where they are squeezed together, a bit like a pogo stick. Tension is where two objects are pulling away from each other, like this toe here, or tug of war. Torsion, very easy. Think about your torso that twists on the human body. Think about like a wet rag or a sponge being wrung out. Bending, and then of course if we've got bending, we have something under tension at the top and compression underneath. Okay, right, so now that we've done that, you can pause, and we're going to go through a few little exam questions. Okay, so exam questions are in the exam paper in Year 11 are split into 3 categories: Section A, Section B and Section C. Section A are multiple choice, Section B short answer questions, Section C much longer. So the question here is, which of these forces is best described by a spring? And second question, which of these forces is best applied by a tug of war rope? Okay, now if you've been listening carefully, you'll hopefully know that a spring is compression and a tug of war, the rope is under tension. Very straightforward and very easy. Slightly longer question. Can you explain the properties of reinforced steel and why it is used? Alright, so we just had a conversation about this. Why is the steel used? So give an example of where it's used, how it's been reinforced, and what is the reason behind that. Okay, you can pause the video there if you want to. Give yourself a little bit of time. And you can see this is worth 5 marks, so we're looking for several bullet points here. So the answer would be concrete bars are placed through the concrete, through the steel bars, so less prone to shrinkage. The concrete's not going to shrink. Less prone to cracking. Can withstand much heavier loads. If you think about a car park that's been built, majority of it you'll see is made out of reinforced concrete. If you think about a bridge underneath is made out of reinforced concrete. Okay, and then the longer question. So this is questions, what we call the Section C question. Explain the difference between a dynamic force and a static force. A little bit tricky. Again, you can pause here and have a go at that. So explain the difference between a dynamic force and a static force, and there are 8 marks here, and they're really looking for a good explanation with some key words. Okay, so a dynamic force, working or lifting load, is a force that will be applied to the linear actuator, such as a ruler resting on the table. It does not move. A static load, this is holding the load, is the force that's been applied to a linear actuator when it's not in motion. The same ruler dropped onto a table from a height does not move. Dynamic, greater force than static. Okay, so remember, dynamic load is a load that's moving, static load is a load that's stationary. Okay, so did we achieve our objectives today? So let's go back to the objectives for forces and stresses. To understand the terms tension, compression, bending, torsion, shear forces and stresses. Yep, we've done that. And then give examples of where different materials are reinforced to increase their strength. Okay, just to remind you of the different types again. So we've got tension, tensile strength, pulling it apart; compression, squeezing it together; torsion, twisting; bending around in a shape but then creating torsion and compression underneath; and then shear, where they glide against each other and cut against each other. Okay, now I hope you've understood that, and I hope you had a go at the questions and you've paused the video as you've gone along. What I am going to do now is send you a Google link, so now go back to the Google Classroom link and complete the quiz. So there is a Google form quiz that supports this PowerPoint. Okay, we will go through this with you again as we return, but I want to try and do sort of one of these once a week with the next sort of 3 weeks that are left. Okay, thanks for listening.